Okay, Jai Hind everyone. Myself Achintya Pandey, Assistant Professor in the Department of Information Technology at Ajay Kumar Garg Engineering College. Today my topic is minimum spanning tree. This topic comes in third unit. Okay, so let's see what is minimum spanning tree. Before minimum spanning tree, we need to know what is a spanning tree, right? So what is a spanning tree? So a spanning tree can be defined as the subgraph and undirected connected graph, which include all the vertices along with the least possible number of edges, right? If any vertex is missed, it is not a spanning tree. Basically, a spanning tree is a kind of tree which include all the vertices of graph, okay, but there not be any closed, there should not be any loop. If it include, suppose there are n vertices, it include all n vertices with minimum number of edges, then that becomes the spanning tree. What need to guarantee is, what need to ensure is there must not be any loop, okay. So we can define a spanning tree consists of n minus 1 edges, where n is the number of vertices. Edges of a spanning tree may or may not have weights assigned to, okay. And if a graph is complete graph, complete graph means every node is connected to all other node, and we want to find how many spanning tree it would have n to the power n minus 2, where n is number of vertices, right? You can justify that. So let's see what are the application of a spanning tree, then we will go to the minimum spanning tree. So these all are some application of minimum spanning tree: cluster analysis, civil network planning, computer network routing protocol. There we require spanning tree. By application of spanning tree, we can analyze the cluster, even network planning kind of civil, computer network routing protocol, just to find the minimum route and all. So let's understand the spanning tree with example. Suppose this is the graph. Graph means closed, okay, and we want to find the spanning tree. So what need to ensure here? Suppose in this graph we just see there are 1 2 3 4 5 vertices. So the tree means what? Tree means it should be rooted and there not be any loop or kind of closed circle, okay. So to ensure a spanning tree, there must have all vertices, all vertex means all 5 vertices, but there should not be any loop like this one. So there are 5 vertices A, B, C, D, and there is no anywhere closed, so this becomes a spanning tree. Similarly, spanning tree second, third, and like this, okay. So we can draw so many spanning tree from a graph, and if the graph is complete graph, we have already identified how many spanning tree. This will be the n to the power n minus 2, okay. So these all are some property of a spanning tree, like already discussed. There can be more than one spanning tree of a connected graph. A spanning tree do not have any cycle or loop. A spanning tree is minimally collected, okay. Means if we remove one edge, this will be disconnected, okay. So that's why we can say spanning tree becomes minimally connected, okay. A spanning tree is maximally acyclic. Spanning tree is sometimes called maximally acyclic. Why it is called? Because adding one edge to the tree will create a loop. That's why it is called maximally acyclic. Acyclic, it is not cycle, but if you add even one edge, that it becomes the cycle, okay. There can be maximum this number of spanning tree if the graph is complete graph. A spanning tree has n minus 1 edges. If there are n vertices, there could be so many edges, but it must have least number of edges, and that's why the least number of edges out of n vertex will always be n minus 1. So that's why a spanning tree must have n minus 1 edges, okay. Similarly, these are some property we can see. So a spanning tree is a subset of connected graph, and there is no spanning tree of a disconnect. If a graph is disconnected, there could not be any spanning tree. So now the topic minimum spanning. So what will be the spanning tree which have lesser number of weight, minimally weight, some of the weight are minimum out of so many spanning tree, then that spanning tree becomes the minimum spanning tree. So how you define minimum spanning tree? So a minimum spanning tree can be defined as the spanning tree in which the sum of weights of the edge is minimum, right? Total sum, okay. The weight of the spanning tree is the sum of weight given to the edges of the spanning tree, right? For example, if the graph is a graph having 4 vertices, so these all are some spanning trees, okay. And if we calculate the sum of the weights of the spanning tree which are shown in the graph like this, okay. So we can just add the weight, these all are the weight on the edges, okay, this one. So if we just sum 5 plus 6 plus 3, that become 5 plus 6, 11 plus 3, 14. Similarly here, okay, sum 11, 13, 10. So which one is minimum? 10, 11, 13. So this one is the minimum. So this will become minimum spanning tree, right? So by this way we can find out, and we can verify there is this spanning tree or not. Just what need to be done? We have to ensure that there must be 4 vertices, yes, and nowhere cycles. So it will be the spanning tree. So this will be the minimum spanning tree. These are the application of minimum spanning tree. What are the applications? The minimum spanning tree can be used to define, design water supply network, even during the computer network routing, minimum MST could be used, okay. It can be used to find path in the map and all that. So there are some standard algorithm just to find out minimum spanning tree out of the graph, okay. So these 2 algorithms are very popular for finding minimum spanning tree. One is Prim's algorithm and second one is Kruskal algorithm, okay. So what the algorithm? So what we have studied, what is spanning tree? The spanning tree is a subgraph which will have minimally number of edges and maximally acyclic. Means if there are n vertices, so there will be n minus 1 edges, okay. Okay, so let's see how to find out MST out of a graph. So one very popular algorithm is Prim's algorithm, okay. So Prim's algorithm is a greedy algorithm, okay, that is used to find the minimum spanning tree for a graph, and Prim's algorithm find the subset of edges that includes every vertex of the graph, okay, so that sum of the weight of the edges can be minimized. Prim's algorithm will start with single node and explore all the adjacent node with all connecting edges at every step, right. So the edges with the minimal weight causing no cycle, this has to be ensured that while proceeding for spanning tree, there should not be any cycle. So let's see the process, how to what are the steps by which we can find out, okay. So these all are the steps to find out minimum spanning tree. First we have to initialize an MST with random chosen vertex. Out if suppose graph is given, right. So we have to suppose any graph like this. Suppose this is a graph, okay, like A, B, these all are the vertex A, B, C and D, okay. So what we have to choose one vertex randomly. You can choose A or B or anyone, right, and then we start. So first we have to initialize an MST with randomly chosen vertex, okay. So we'll see with the example. Now so first we have to initialize an MST with any chosen vertex. Now we have to find all the edges that connect the tree in the above step. From the edges found, select the minimum edge and add it to the tree. Repeat step 2 until the minimum spanning tree is found. Means we have to repeat the step until all vertex are encountered with condition there should not be any cycle. These are few applications of Prim's algorithm. This Prim's algorithm can be used in network designing. Okay, Prim's algorithm can be used to make network cycles. It can also be used to lay down electrical wiring cable. Okay, so these are some application of Prim's algorithm. Suppose this is the graph. Okay, so we have to identify, we have to draw, we have to find minimum spanning tree of this graph using Prim's algorithm. So what we do, there are 3 steps. One is what? Choose any vertex, and from that vertex we will draw the edges, and we will find the minimum weight edge. Okay, so suppose this is the graph. So how many vertex are there? 1, 1, 2, 3, 4, 5. So there are 5 vertex. So this is the step 1. First we have to choose a vertex from the above graph. Let's choose B. You can choose any vertex. Okay, so here to proceed, we have just choose the vertex V. Okay, so from B how many edges? B to C, B to C and B to D. This is the connected, graph. Every vertex is connected to other nodes. Okay, so which one will we choose? This is the minimum. Okay, so B to D is minimum out of B to C and B to D. So what we will select? B to D. So first step is to choose any random vertex. For example, here B. From B there are 2 edges. We will take minimal weight edge. Okay, so B to D is minimum. Now we have 2 vertex. So B, what are the edges from B to B, and what are the edges from D? We have already included the edge from B. Now we have to choose the minimal edge from vertex D. Okay, so from D we have D to C, we have D to E. Which one will be minimum? D to E. So in the next step we will draw D to E like that. Okay, so we can see this is the next step. We have included D to E. Now we have 3 vertex B, D, E. From B we have already identified. Now select the edge C, D. Okay, why we select C and D? Suppose we have B, D, E. So what we see? We will see from B to C 10, D to C it is 2, and E, from E how many edges? E to D, E to C. Okay, so out of that which one will have weight less and which is not included yet? So D to C, because D to C is having minimal weight, rather B to C which is 10, rather E to C which is 6, rather yes. Okay, so out of 10 to 6 which will be minimum? 2. Okay, so we will draw D to C. So D to C, and there is no cycle. So how many vertexes come? B, C, D, E. One is not come, A. Okay, so what we will see? From B, C, E we will find the edge which will have minimum weight and there should not be any cycle. Okay, so just B, C, E, B, C, E, just find out in this case B, C, E. Okay, so C to A, this will have the only edge. Okay, because from B is already included, from E is already included, so we have last C to A. So this is the minimum spanning tree. We will only sum the weight of these edges. We will find the cost, or you can say total sum. So this will having 10. Okay, so this is the step of Prim's algorithm. So in Prim's algorithm what we do? First we identify any random vertex. From that vertex we draw the edges. We will select the minimum out of the edges to ensure that there should not be any cycle. So this is how you find MST. Next is Kruskal algorithm. Short of Kruskal and Prince both are the algorithm which is used to find MST out of any graph. Okay. So there is just a little bit difference with the process. First, here we sort all the edges from minimum to maximum. Okay. If there are suppose a graph which will having so many edges, so we will write the edges in increasing order of their weight. Okay, means we will sort all the edges and we will write. Okay, so the first step is sort all the edges from low weight to high. Now take the edge with the lowest set and add it to the spanning tree. If the edge to be created a cycle, we will ignore it. Okay, first sort all the edges from low weight to high. Now take the edge with the lowest weight. Okay, just because we are going to create MST, and add it to the spanning tree. If the edge to be added creates a cycle, just reject the edge. Continue to add the edges until we reach all vertices. Simple. In Prim's algorithm, we just identify the vertex. What we do? Here we identify the edges over which the weights are written, and we sort these edges or we rearrange the edges in increasing order of their weight. Okay. So just see by the example like this. Suppose this is the graph. So how many vertex are here? 1, 2, 3, 4, 5. There are 5 vertex. So these all are the edges: A to B, A to C, A to D, A to E. Okay. So which one is the minimum weight? A to B or B to A. So first we will write this one in increasing order of the weight. Okay. So this is the minimum weight. So first we write AB. Then next minimum, this one. So we write AB, then DE. So first we have just written the weight of the edges like AB, AC, AD, AE, BC, CD, DE. These all are the edges. How many edges? 1, 2, 3, 4, 5, 6, 7. Corresponding weight of the edges are this. Now by this way we can sort. So we rearrange the edges like here. So we will write first is AB, this one. Then we write DE. So here it is written. Okay, this is AB and DE, BC, CD, AE, AC and AD. Okay. So we have arranged like in increasing order. Okay. So we have identified the edges in increasing order of sequence. Okay. Now what we require to do? We will create the MST. So what we do? First we will write the edge AB. So in the next step we can see this is the AB. Then next edge will be, which one will be minimum? This one, DE. So in the next step, any step 2, AB and DE. So you can identify the difference in, Prim's algorithm, where we start from the vertex, but in this Kruskal algorithm we start from the edge. We continuously add edge, but in Kruskal we continuously add vertex, and the edge which is minimum will be included. Okay. So this is the second is next vertex, next minimum AB, DE, then BC. So BC. Okay. AB, DE and BC. Then CD. So in the step CD. Okay. Similarly AE, AE, CD. Just we have to find whether adding edges causes cycle or not. So let's identify CD. CD, even we add this CD, it will not cause any cycle. So we can add. Suppose if we add vertex AC, so this will create cycle. Okay. Okay, so we will not add AC. So here we have to just, here we required, we need to ensure that no edge should be added which create cycles. That need only to be ensured. So CD will not cause any cycle. So in the next step we have added CD. So we have A, B, C, D, E. How many vertex? 5 vertex, all are included. There is no cycle. So this will become the MST. Okay. And these are the weight written over here. We can just sum the weight and we will find the sum of the weight, right? So this is the AB plus DC plus this is the weight 1 plus 2 plus 3 plus 4, 3, 6 and plus 4, 10. So this is the MST. Okay. Okay. So what we have seen in this lecture. So we have just find what is MST. Before MST we have studied what is spanning tree. Spanning tree is what? A subgraph which include all the vertex of graph, but all the vertex of graph with minimal edges, means if there are n vertex, so minimal number of edges will be n minus 1. So there will be only n minus 1 edges and it would be maximally acyclic. Acyclic means there should not be any cycle, but adding just one more edge will create the cycle. That's called maximally acyclic. Okay. Out of the spanning tree, the sum, total, if we sum all the weight, out of that weight, which one will minimum will be as a minimum spanning tree. So there are two very popular algorithm which is used to find MST. One is Prim's algorithm, second one is Kruskal. We have seen in this, right? In this we have followed the Corman and some internet material, right? So thank you everyone. We will meet next in my next video. We will see further. Okay. So thank you everyone.